Hey guys, welcome back. Today is day 42 and we're going to continue talking about the properties of exponents. It's really important that you understand all of the properties that we did in day 41. So if you don't have knowledge of that, please go back to day 41 first because we're kind of adding on today. All right, so today we're going to talk about the power of a quotient property, and what a quotient is, it actually looks like a fraction. So our example here, we had 2/3, okay, to the third power. And we represent 2/3 to the third power really as 2/3 times 2/3 times 2/3, okay? All right, kind of squeezing it in there. Now, if you multiply fractions, you multiply the numerators, which if you took 2 times 2 times 2, you would get 2 to the third, and that would be divided by, then you multiply the denominator, 3 times 3 times 3, which would be 3 to the third. Okay, so you can see to find the power of a quotient, you find the power. Okay, it says of each number, but since our numerator and denominator isn't necessarily going to be a number, I'm going to type right in here numerator and denominator, okay, instead of number, because it's not always a number. All right, so in the event we took 2 to the fifth, we raised it to the third power. That means we take the numerator, raise it to the third power, and denominator to the third power. Now, if they're numbers, we typically evaluate, multiply them out. We get 8 over 125. Okay, but with variables, we just actually put the variable, we raise it to the power. In this case, it's going to the m power, and b would be to the m power. Okay, so our first example in number 1, when we have 3/2, that's 3 to the third and 2 to the third. Okay, 3 to the third would be 27, 2 to the third would be 8. Okay, and we're not going to turn it into a mixed number in algebra. We're going to keep it as an improper fraction. Okay, number 2, the numerator goes to the third power, and so does the denominator. And I'll be honest, the most mistakes I see are in the denominator. A lot of kids forget to take the y and raise it to the third power. So take your time and really do your steps. Okay, number 3, we have a negative 7x. Okay, so you're going to want the negative number, the negative to go with either the numerator or denominator. You don't want to do both, because if it was both, it would be a positive 7x. But you want, in this case, I'm just going to take the 7 and make it a negative 7 and square it, and the denominator is going to be x squared. So when I evaluate it, I get 49 over x squared. Okay. All right. So now we're going to pull in. All right. We're going to just go ahead and practice some more. This would be a to the fourth, b to the fourth. Okay. Again, here's another example with a negative. So it's negative 5 to the third over y to the third. And that's going to be 125. It's going to actually be a negative 125 over y to the third. It's a negative in there. Okay, number 6, be careful. All right, so we're going to take x squared and we're going to square it, and then we're going to take 4y and we're going to square it. That would be our first step, okay? So I look at the numerator, and x squared squared, the rule is I multiply when I'm taking power to a power, so I get x to the fourth, okay? Now, the denominator, don't forget, the 4 is being raised to the second power, and so is the y, okay? So our final answer would be x to the fourth over 16y squared. Okay, so that's the first 6 that we did. All right, now we're going to get a little bit more complicated. Okay, so notice the numerator is 5x squared, and we're raising that to the third power. We're doing the same thing for the denominator, which is 5y to the third power. Okay, you should really do that first step, simply because many people forget about the denominator. Okay, now I'm going to take the numerator, and I'm going to take every factor inside the parentheses and raise it to the third power. X is going to be to the 6th power, because 2 times 3 is 6. All right, now with the denominator, it would be 5 to the third, y to the third. Okay, so notice we've got 5 to the third divided by 5 to the third. You can cancel them out there, or you could evaluate them like this, and then you're going to see that 125 over 125 is just 1. So our final answer is x to the 6th over y to the third. Okay, so that would be for number 7. All right, number 8, let's look at this. Okay, our numerator, this would be a to the 10th. Denominator would be b to the 5th. We're multiplying it by 1 over 2a squared. Now with fractions, you multiply the numerator going straight across, so a to the 10 times 1 would just be a to the 10th. And then down at the denominator, we're going to multiply straight across. I like to pull my coefficient out front, so this would be 2a squared b to the 5th. All right, just to keep myself organized, I like to put the variables in alphabetical order. Always put the coefficient out front, and if there's a negative coefficient, definitely put that negative way out front, not in the middle, because it makes it look like there's two separate terms. Okay? All right, we're not done yet, because if you notice, we have two occurrences of the a variable. You should only have one occurrence of each variable when you're complete. Okay, so now we're dividing a to the 10th divided by a squared. Well, we learned last class that you subtract the exponents when you have the same base. So when we do that, we end up with a to the 8th divided by 2b to the 5th. Okay, and then the last one here, number 9, this one gets a little bit tricky. Okay, so let's be careful with it. Oops, I got this weird little line here that doesn't want to erase. There it goes. Okay, get rid of those lines. Okay, so let's watch this one. All right, so in this case, we're going to take the numerator 2s, raise it to the 5th power, all over 3t, and that's also to the 5th power. And we're multiplying that by t to the 8th over 16. Okay, so 2 would be to the 5th power. We're taking every factor, s to the 5th, times t to the 8th. Okay, and then the denominator, we would have 3 to the 5th, t to the 5th, and that's going to be times 16. Okay, so getting kind of messy here. Let's evaluate out. 2 to the 5th is 32, s to the 5th, t to the 8th, and then we're going to evaluate 3 to the 5th. We get 243, t to the 5th, times 16. Okay, so at this point, I could multiply 243 times 16 and get a really big number, or I could recognize that 16 is a factor of 32. 32 divided by 16 is just 2. So we got the 2 in the numerator. Now we've got a t to the 8th divided by t to the 5th. That's going to be a t to the 3rd power. Okay, so we're left with 2s to the 5th, t to the 3rd, all divided by 243. Okay, so that was a little tricky. All right, so moving on. Okay, definition of 0 and negative exponents. A to the 0 power is 1. Okay, we learn anything to the 0 power is equal to 1. So 5 to the 0 power would also be equal to 1. All right, as long as we don't have 0 to the 0 power, because that's where we said we're up for debate, but that would be undefined. Okay, now negative exponents. We never want to have an answer with a negative exponent. So it's important to note that a negative exponent can be turned into a positive exponent by making the reciprocal of it. Okay, what does that mean? All right, it means that if I had 3 to the negative 2, that's the same as 1 over 3 squared, which is 1/9. Okay, notice we end up with the reciprocal. All right, so 2 to the negative 1 would be 1 over 2 to the 1, which would be 1 over 2 rather, or 1/2. Okay, and it works the other way too. Okay, so if we had a whole number 2 and we wanted to take the reciprocal of it, okay, all we're going to do here is this would be 1 over 2 to the negative 1. Okay, those are equivalent. All right, let's look at some examples of that. All right, 3 to the negative 2 would be 1 over 3 squared, which is 1/9. 7 to the 0, well, anything to the 0 power is equal to 1. 1/5 to the negative 2 means we can take the reciprocal, which is 5 over 1, and we can square it, and that would actually just be 5 squared, which is 25. Okay, 0 to the negative 5 power would be, if we took that, it would be, actually we cannot do that because it's undefined, because it's like saying 1 over 0 to the 5th, and since we can't divide by 0, that's undefined. So that leads us to our rule that a to the negative n is defined only for non-zero a. Okay, so it can't be 0. It can be anything else, but it can't be 0. Okay, so 5 is easy. 2 to the third is going to be 1. Okay, 6 is going to be 1. We take the negative 8, and it's going to be to the negative 2 power, so we're going to say 1 over negative 8 squared. Okay, we took the reciprocal, made it positive, so that's 1 over 64. Okay, 1 over 2 to the negative 3, if I take the reciprocal, I just get 2 to the third. I can evaluate it, and I get 8. All right, so this, if I multiply power to a power, I get 4 to the negative 4, which is equal to 1 over 4 to the fourth, which is going to be equal to 1 over 256. All right, and then 1 over 3 to the negative 4, the reciprocal would just be 3 to the positive 4, which is 81. Okay, so 81. All right, and then the last one here, if I take 6, I have the same base 6, so I add my exponents. I get 6 to the 0, and that's equal to 1. Okay, so to simplify all these, we want to write them only using positive exponents. Okay, so I'm going to show you how I do it. There's multiple ways to do these, okay? This would be 2 to the third, x to the third, y to the negative 15. Since I can't have negative exponents, 2 to the third is 8, and x to the third would be the numerator, and I'd simply move the y to the negative 15 to the denominator, and I'd make it positive. Okay. All right, looking at the next one, x is to the negative 5, so I'm going to start out. On the bottom, I've got y squared. I'm just going to move my x to the fifth down to the bottom, and since there's nothing left up top, I'm just going to put a 1. So it's 1 over x to the fifth y squared. Again, I like my variables in alphabetical order. Okay, so looking at this, I'm going to take each of the factors, and I see negative exponents in there, so I'm just going to move them to the bottom, like that. There's my answer. Okay, 14, it's to the 0 power, so I'm just going to give you an answer of 1. Okay, in that case, f cannot be equal to 0, and g cannot be equal to 0. Okay, because that would make the whole thing equal to 0. All right, looking at number 15, when I set this up, I've got 2h to the third. Okay, now my j to the negative 3, I'm actually going to pull that down to the bottom. The 3jk stays the same on the bottom. I'm going to move the j to the third to the bottom and k to the fourth up top. Okay, now I can only have one occurrence of the variables, so 2h to the third, k to the fourth, and it's going to be 3. J is going to be to the fourth power because I'm going to add these two, and then I get k. Now my final step, I just divide k to the fourth divided by, remember there's a 1 there, so my final answer would be 2h to the third, k to the third, divided by 3j to the fourth. Okay, that was a little tricky. All right, and now the last one here, how I would set it up, and again, you can do it your own way. There's different ways to do it, but I like that 2x to the negative 2. I'm immediately going to pull that down and make it positive. My negative 4x is out front, x squared, okay, y squared. All right, so up top, I'm just left with this y to the fifth. All right, I'm now going to take the y to the fifth. Okay, so we've got y to the fifth is the numerator. And down in the denominator, I've got a negative 4 x squared y squared. Now I'm going to take my factor 2 and square it, and x and square it. So y to the fifth divided by negative 4x squared y squared 4x squared. Whew. Okay, now we're going to take the negative 4 times 4, y to the fifth still up top. We get negative 16. X to the squared times x squared is x to the fourth, and then y squared. Okay, but we're not done because we have 2 occurrences of the y, so we need to subtract. I'm going to write the final answer up here. Y, 5 minus 2 is 3, so y to the third divided by negative 16, x to the fourth, and that would be our final answer. Okay, thanks guys. Bye.